Welcome to Calculus Vectors. I'm Mr. Brock, and I want to take you through this first lesson today, just an introduction to vectors themselves. Um, Basically, what we're going to do today, I'm just going to take you through the day one sheet. There's a link for it here, but there's no need. You've got the copy right here. You can take a look and see what the course is going to be about. Um, Basically, we're going to split the course into two main parts. The first one will be the vectors, and the second one will be the calculus stuff, which is more in line with your advanced functions course. And we just take it a little further that way. So that'll come in the second half of the course. When we take a look at the breakdown, every time we do an evaluation, you're going to see the four categories that will be assessed. Knowledge is the most important. It's the most weighted. It's 40%. Application is 30, thinking 20, and communication is 10. And I will be very picky with communication. I'll talk about that a little bit later when we get into the vector work itself. We'll discuss briefly about what we're going to be doing as far as the makeup of the course itself and the final evaluation. There will be some evaluations that we do that will be counted towards your final 30%. Okay, if I take a look quickly at the resources, we can see our Octo 5 calendar here, and I've got them kind of set up, and basically it's unit number with lesson number on it, and that's how we do it. For example, today is unit 1, lesson 1. We'll do 2 and 3, and then tomorrow we'll end up with unit 1, lesson 4, 5, and 6, and so on. But when we take a look at the different assessments, you'll notice that on the 17th of the month, we have a culminating activity number 1 that will be part of your final mark. It will be the vector portion, and that will be for cohort A if we're continuing to go back and forth from cohort A and B. If we're all online, then we'll make some adjustments there. And then the next day, the cohort B will be in, and they'll do their culminating activity in that. Again, it'll be a different one, obviously, than the day before, but it'll be worth the same amount. And then finally, at the very end, everybody will be doing their culminating activity for the calculus portion, okay, on the 9th of March. Okay, so that'll be for that. We'll go through exactly when we're doing things and how much they're worth and all the rest of that at a later time. Okay, back to this first day. You can read through these on your own. You have it in the OneNote. Okay, I always include the inventory for the textbooks. There's no need for this because we have a digital version. You have them in OneNote as well. If we take a look at the tab Student Textbook, they're all there. And you notice that all these links, the online links here, you can see they're numbered by their starting page number. So if you need whatever page you're looking for homework, or at least maybe for some references, okay, they'll all be listed on this page. All right, it's very inclusive. It has everything. So when we take a look at what a vector is, what I want you to do is I do want you to look at the Despicable Me video here. Former student showed me this, and I thought, oh, perfect. We'll put this in. So you can pause this recording here, watch Despicable Me, and then you can unpause and we'll continue on. So after seeing that, we can see that a vector itself, okay, basically has two quantities to it, or two parts to it. It has a magnitude, all right, but it also has a direction. All right, scalar quantities, which you've had in the past, a lot of you, and those of you who haven't taken physics that really haven't touched vectors really, but scalar quantities just have a magnitude. They have a size, right? We talk about the distance, 100 meters, or the mass of 78 kilograms, or we use pounds or whatever. It's just a matter you're a simple quantity without a direction. When we start adding a direction, that's when we start getting into our vector quantities, and that's where we're going to be looking at and starting out today. So today's lesson is basically a very simple introduction. Let's understand what these vectors are and how to write them. Okay, that's really what we're doing right now. So I'll take you through this worksheet here. So a geometric vector, if we talk about that, there's two types of vectors we're going to be dealing with, a geometric and an algebraic. Okay, and we'll start off with the geometric to understand it, and that's most of what you've done with the in physics that you've taken is the geometric vectors. I know that you have done algebraic vectors, and we'll get into that a little bit later in a later lesson. So anyway, a geometric vector is represented by an arrow, and it's called a directed line segment. Literally, that is a vector, okay? We have our basically a start and an end, all right? It has a specific length, which represents the magnitude, and the arrowhead tells us the direction that we're going with, okay? We can start here and we end here at a specific magnitude, okay? We can have, when we have, write these down, that's why we need like rulers or grid paper or whatnot, so that you can have a specific scaled example, okay? If I were to look over at, a specific displacement, let's say it's 40 kilometers northwest, when I go over and try to write that northwest here, we know that north is always going to be up your page. Okay, just very quickly, we know that that's north here, and west is obviously to your left. Okay, the west there. Northwest, we know is 45 degrees in that direction, and what we have to do is we have to go with 40 kilometers. So what I'm going to do is I'm going to say, okay, to make it simple for myself, if I start here, I'm going to say each diagonal is 10 kilometers, or represents 10 kilometers. So I have my 30 here written there, then I've got my 40, and that's going to be my northwest. Okay, without that little mark right there. Oops, there we go. All right. So this represents, we've got our 40 kilometers per hour, all right, our magnitude, and then we have its northwest, one way of writing it there. Okay, scaled, all right, scaled. A weight, 900 newtons downward, again, pretty simple, we could do. Figure out a scale, easy enough to do, maybe by hundreds and go 9 units down. Velocity, again, 60. I did velocity instead of displacement before, but that's fine. And then you've got your velocity of 60 kilometers per hour west, okay? It always has that direction, all right? How we take note of our vectors, all right? We've got, basically this is our preferred method, these two right here's, okay? If you take a look at on my diagram there with the vector AB, notice what we say is we've got the starting point is now called the tail, and the ending point is the head. So it gives us that direction as well, from tail to head, always. All right. As far as writing A to B down, when we have our initial point there, we always have our initial point to start first. Our head is second, and we use what's called this harpoon. All right. Now, the textbook itself does not use a harpoon. The textbook itself uses this arrow. And what that is a ray. It is not a vector. I've seen many other higher level math textbooks dealt with. It's always a harpoon. Okay, and so I'd like you to make sure that you use the harpoon as well, part of your communication skills. Okay, instead of just doing the labeling the tail and the head, we can also label it with a lowercase letter. Okay, and when we when we use the lowercase letter, again, we use the harpoon over top of it. Okay, so in this case, we have vector V. All right. So, and this again, I just put a note here. Notice we have a similarity between line segments and lines, right? Because again, if we're doing line segments, the endpoints there are listed with capital letters, and then inside we could have a lowercase letter, okay, for the whole length. So it's the same way with vector notation, so nothing new there. We have another symbol, okay, and this represents the magnitude of the vector. And what we do is we use the absolute symbol sign around, okay, the vector itself. All right, and that will represent, and we will say the magnitude of vector. So in this case, we've got the magnitude of vector AB. If we're using V as the vector, we say it's the magnitude of vector V. Okay, so the reason why we use the absolute value symbol is to say that the vector itself is non-negative. Okay, they're non-negative quantities. 0 is a quantity, it's non-negative. That's why we say non-negative and not just positive, okay, because it can be a vector itself. We'll talk about those in another lesson. All right. The magnitude of the above, you can see those, you know, what the magnitudes are from the above as far as vectors A, vector B, and vector C are. Okay, it makes sense. All right, it's just the numerical value of it. All right. Now, one of the things that we've used, you can see that I've already mentioned that I know that you've done this in physics itself, dealing with vectors. Okay. The other thing that we did with vectors, and this was way back in grade 10, is when we were doing shifts of different functions. Okay, we started that with the quadratics. Okay, not the a value, but the h and the k value when we talked about shifting functions and shifting quadratics. If we were to very quickly use this quadratic here, and maybe we have, you know, label 3 points. There's A, there's B, there's C. Oh, sorry, not BB, but BC. We can do a horizontal shift, left or right. And let's say we're doing a horizontal shift and we've got 1, 2, 3, 4, 5, 6, 7, 8 units. Okay, to the right there, and we'll shift this over to, let's just call it A prime. All right, then we shift everything over to the right. Okay, 8. So C can come over 1, 2, 3, 4, 5, 6, 7, 8. And we'll call it C prime. B, 1, 2, 3, 4, 5, 6, 7, 8. There's our B prime. And if we do this to every single point, we're going to have our new graph there. Okay, now we did that shifting left, right, up, and down. We didn't take note of basically what the vector would be, right? We can have a vector here. We know that a vector A prime, all right, is 8 units to the right, right? 8 units to the right. Well, notice vector B prime is also, is also 8 units to the right. Vector C and C prime, or vector C prime, is also 8 units to the right. Okay? We call these equal vectors. Okay? Equal vectors. Why are they equal? They're equal because their magnitudes are the same, and we can write that out like this. Okay, this is B prime, and all the magnitude for C prime, they're the same. And they're in the same direction. Okay? Equal vectors have the same magnitude and the same direction. Okay? And if you come up with two vectors that have equal magnitude or in the same direction, you know that they're equal. So it's an if and only if statement. Okay? It goes backwards in reverse. All right? So that's what an equal vector is. And we have that written in here as well, that we've got them as equal vectors. All right? But the other thing, okay, the other thing we can look at is, well, what if we went the other way? What if we went from the prime graph back to the original graph, okay? So what we do is we start with A prime and go on to A. We map on to A. Well, there's our vector there. And what this is, it's 8 units left. And we notice that B prime B, the vector there, is also 8 units left. C prime C, again, 8 units left. So what we have is the magnitudes are the same, okay? So A prime A has the same magnitude as A prime, okay? But they're in opposite directions, okay? Since they're in opposite directions and they have the same magnitude, we call them opposite vectors. They are opposite vectors. Oops. Okay, opposite vectors. And what we can write here is we can say, well, A prime is equal to negative A prime A. This is how we symbolize opposite vectors. Okay, we use the negative. All right, that's how we start throwing in this negative there. All right, you see how that works? And you can read that through the same way with opposite vectors here. All right, so again, at any time, if you need to go back and take a look at it, you have the ability to pause, rewind, go forward at your own pace. Okay? Now, here's the neat thing that we did. If you take a look at A, B, and C that we did in this diagram here, and the 3 vectors, well, this vector here, they are in 2 different spots, right? But we say that they're equal. Equal vectors do not have to be in the exact same spot. We can put them anywhere so long as they maintain their magnitude and their direction. Okay, it's the same thing with the mapping on this one here, going from one rectangle to the other rectangle. Okay, AW, and I'll just draw a little thing, AW here so you can see it there, is the equal vector to DZ. All right, and we literally say that. We can say that AW vector is equal to the DZ vector. All right, and we're going to use those. All right. So it's the one thing to take a look at. So what we do is our last thing for this unit, and that was it, just understanding vectors, how they work, okay? So we're going to assume that we have a parallelogram and it's ABCD, all right? List 2 pairs of equal vectors. So what I want you to do is I want you to pause the video, all right? Answer A and B, and then unpause it, and we'll go through a couple of examples to see if you have them as well. So what we have for equal pairs of vectors, listing 2 pairs of equal vectors, we could say that we have the vector AB is equal to vector DC. We could also have that vector DA is equal to vector CB. Remember, everything in the same direction. All right, those are just a pair that you could use. Now, opposite, if we start with vector AB, the opposite direction from AB would be CD, right? Those are equal to each other. We could go that way. Or you could say AB is equal to negative DC. That's how you can show that those are opposites, right? Using that negative part of it. All right. These two here, we can see would basically be the same vector. All right. If we use DA, vector DA, we know the opposite to DA would be vector BC. Or again, we could use negative vector CB. Okay, so try your hand at these. All right, take a look at the textbook questions listed here and work through those